For the 50th problem on the second ACT practice test, all of the following graphs have equal scales on the axes. One of the graphs shows only points for which the y-coordinate is 1 less than the square of the x-coordinate. Which one? So with this problem, we basically have to take this sentence here, that the y-coordinate is 1 less than the square of the x-coordinate, and we have to figure out an equation from this sentence. So let's think about it. The y-coordinate is, usually when you see the word is, you can think equals. So we can write the y-coordinate equals 1 less than the square of the x-coordinate. So the square of the x-coordinate, that's just x squared. And we want something that's 1 less than that. So we can take our x squared and subtract 1. So this equation here, the y value is essentially 1 less than the square of the x value. And at this point, we just have to learn how to graph this. Now, if you were to graph simply just y equals x squared, let me draw a quick sketch of what that would look like. So I claim that this graph represents this equation. And if you have a graphing calculator, you can just check it on there. But you can also check it by just plugging in numbers. So if we plug in 1 for x, so that'd be this point, then you have 1 squared. And 1 squared is just 1, so the point at 1, 1 would be on this graph. But if you put in the value 2 for x, and then you'd have to square it, and 2 squared is 4. So the point 2, 4 would be on the graph as well. So for this particular quadratic function, it's symmetric about the y-axis. But all quadratic functions will have some line of symmetry, where you essentially have a mirror image on either side of that line. But in this case, it's the y-axis. So if you put in the value -1, you get back -1 squared, and -1 times -1 is +1. So -1, 1 is on a graph. But also, if you put in -2, -2 times -2 is simply +4. So -2, 4 would be on a graph. So you can see if you put in 2 or -2, you still get the value of 4, which is why you get this symmetry here. Now, this is the graph of y equals x squared. But we're concerned about the graph y equals x squared minus 1. And the only difference between these is that essentially all of our y values along this curve would be shifted down 1 unit. So for instance, in here, when I put in the value 2 and I squared it and I got 4, so that gives us this point here. But up in this graph, if I put in 2, I square it and I get 4, and then I have to subtract 1. So we'd see the point 2, 3, which would be right around here on a graph instead of up here. So in the end, everything gets shifted down 1, including this vertex here. So our new vertex for x squared minus 1 would be down here. And then our curve would look pretty much the same. And again, this is just a rough sketch. But the main idea is that it's the same curve, just everything is shifted down 1 unit. So we have to now look at our answer choices and figure out which set of points would represent this. And you could use process of elimination. So obviously, these would not be correct since they're lines. And then this has the shape of a quadratic. You can kind of see the curve happening there, but it's upside down from what we're looking for. So we know that's not right as well. And looking closer at our last two choices, they're very similar. They both look like quadratics. But we're expecting to see a vertex down here at this -1. And you can see that here, since we have a point right there. But on this one, no points go below the x-axis. And the point on the y-axis is at a +1, which we wouldn't see on our graph, since our graph is only going to cross the y-axis one time and it's going to cross at this -1. And since this crossing of the y-axis is a +1, we know this is impossible. And you could verify this, since it does cross at this -1, and it does follow that same basic pattern of a quadratic. So in the end, this choice letter J would be the final answer.